Okay, the next thing we're going to talk about is a topic called scientific notation. And what scientific notation is, it's a way to allow us to write very, very large or very, very small numbers, okay? Now we do lose a level of precision with this notation because we end up rounding things off. So if you need a really, really precise number, we wouldn't want to round it off, okay? But if we have colossally large numbers, for example, generally speaking, we don't need to know it, if it were a distance, for example, and we've got trillions and trillions of miles as part of this distance, we don't care about the little, inches and centimeters, right? Because we're talking about trillions of miles. So we need to understand the context a little bit of the number before we know if it makes sense to use this notation or not. But the basic anatomy of the notation is this. We're going to have a single number, and I'll just use numbers instead of letters. Single number, and then a decimal point, and then maybe one or two more numbers. Okay, here's where we would round it off if we had a really big number. We'd round it off somewhere. And we're going to multiply that number by some power of 10. So in this case, I just have 10 to the 4th. So we have a number, a decimal point, one or two more numbers rounded off, and then times some power of 10. This is a notation we can use instead of writing it in what we would otherwise call an ordinary way or a standard notation way. If I actually perform this multiplication, what am I saying here? 5.12 times a 1 with 4 zeros times 10,000. So that's going to be 51200, 51,200, right? This is a different way to write that same information of 51,200. All right? Now you could argue, well, this looks more concise than this. This doesn't look very good at all. Well, it's really beautiful for huge, big numbers. Okay, 51,200 is not all that big. Now, if I was going to use this notation, let's say my actual number was 51,204. You notice this here, 5.12 times 10 to the 4th, I've lost the significance of that 4 there. See that? Because I rounded it off. Because when I put it in this form and then I multiply by 10,000, the 4 is gone. All I have is 52,200. So we will round and lose a level of precision with this method, but again, it's good for really, really large or really, really small numbers. So this would be a quote-unquote large number. A small number would be some number between 0 and 1. That's what we mean by small number. We don't mean really, really negative. We mean between 0 and 1. So let's say I have 8.49 times 10 to the negative 3rd power. Okay, we're going to have negative exponents with scientific notation dealing with small numbers. And it's okay to leave those negative exponents. In previous videos, I said we need to clear those negative exponents out of there, and we should do that other than scientific notation. So what does this mean? If we kind of expand it out, we know what that negative 3 exponent means. It really means 8.49 times 1 over 10 to the positive 3. That's what it means, right? And if we think fractions, I've got a fraction times a fraction there, which is really 8.49 divided by 10 to the 3rd power. And if we really expand it out, that would be 8.49 divided by a 1 with 3 zeros, which is 1,000. So it means I got to move that decimal 3 places to the left, so I'll get 0.0849. 3 places to the left. Oops, and I didn't move it 3, I moved it 2. 0.00849. 3 places to the left, my bad. Okay, 1, 2, 3, got it. All right, that's scientific notation. That's a really, really small number. You could argue it's not that small, but the notation will really work out well when the number is really small. Okay, so that's what we're talking about here with this notation. So example 1 is going to just ask us, is a certain number scientific notation or not? So I'm going to pull the book up for that one just so we can see the examples. we're just giving kind of yes or no answers here. Which one of the terms is expressed in scientific notation? Part A says 4.7 times 10 to the second power. That is in scientific notation. I've got a single number, decimal point, another number, times some power of 10. That's scientific notation. Okay? Part B is not scientific notation because I want to have a single number before that decimal, not a zero. So I don't want to have 0.2. I would want to express that a little differently. Otherwise, it is in the correct form, but it's not because we don't have a single number and then a decimal point. Part C has got the single number and the decimal point. The fact that it's negative doesn't matter. However, the problem with Part C is that I'm multiplying it by 5 to some exponent, and that's no good. It has to be 10. Part D is good. Okay, now it's awkward because we're multiplying by 10 to the power 0, and 10 to the power 0 is just a 1, so it's just 2.7. It would be kind of odd to write it in that notation, but it is correct. It does fit the bill. So part D would be correct. E is not good because I don't have a single number and then a decimal point. Okay, otherwise it would be. F is okay. I don't see a decimal point after that A, but it's there. I've got a single number, the decimal point, times 10 to some exponent, so that's good. Part G is no good because it's a division sign instead of a multiplication sign. Okay, and scientific notation always has a multiplication sign. Okay, let's do example 2, and we will convert these numbers from scientific notation into what the book calls ordinary numbers. Most textbooks refer to that as standard notation, just the regular good old numbers we always deal with. So if somebody gave us 3.6 times 10 to the 4th power, it'll be very similar to the one I just did above. Well, multiplying by 10 to the 4th power just means that decimal is going to be shifted 4 places to the right. So let's move it 4 places to the right. The first place gets me past the 6, so I need 3 more places that I'll have to fill in with zeros. So that'll be 36,000. Okay, part B, 2.8 times 10 to the negative 2 power. Here's a negative exponent, so my decimal is going to be shifted to the left in this case, 2 positions, so 1 position gets me past the 2, so I've got 1 more position. Now this leading 0 never counts as any of those positions, but I really like to have a leading 0, then my decimal point, so I had to move 2 places, so I need 1 leading 0 here, and then a 2.8, 0.028. Part C, 1.1 times 10 to the 0 power. Again, a little odd to have 10 to the 0 power, but it is the notation. It works. It fits. 10 to the 0 is just a 1, so it's 1.1 times 1, so it's 1.1. Part D, negative 6.9 times 10 to the, what does that say? Negative 5th power. 5 decimal shifts to the left. The number is still negative, okay? The negative exponent has nothing to do with whether or not the number is negative. The number is negative because there's a negative sign in front of it. So it's a negative number. That doesn't change. This negative 5 is all about shifting the decimal to the left 5 positions. So I'm going to have my decimal point and 4 leading zeros, and then my 6, 9. Okay? And finally, part E, I've got a negative 9.7 times 10 to the 6th power. It's a negative number, but it's going to be a big negative number because I've got a nice positive exponent there. So I'm moving that decimal 6 places to the right. The first place gets me past the 7. I need 5 zeros after it. I can go back in and fill in my comma, so it's just a big negative number of negative 9,700,000. Okay? Alright. So that's going from scientific notation back to a more ordinary standard notation. What if we want to go the other way? Okay? That's what our next example is going to ask us to do. If you look at example 3 on page 244, we're asked to take the number 285 and convert it into scientific notation. Okay? Well, we need to find the decimal. Okay? And if it's not shown, it means it's there. and I want to move the decimal so that I only have one number and then a decimal point. So I got to shift it 2 places. So that's going to be 2.85. You know, we kind of have to think backwards now. I had to count backwards 2 places, so we have negative on the brain because I counted to the left, but no, I'm expressing the number 285 as a scientific notation number. So I need a positive exponent there, okay, because it's going to go back 2 places if I actually do that multiplication. Okay, so we take that decimal at the end, we move it to one number and then the decimal point, and we have to figure out how many decimal shifts it took us to do that and write the number. Part B, 0.007. Okay, it's a small number, less than 1, so I'm going to have a negative exponent on there. What am I going to do? Take this decimal 1, 2, 3 places, so I'm going to call it 7 times 10 to the negative 3. Everybody cool with that? C, 9.1, okay? It's already kind of in the right format, right? I got a number and a decimal point, I got a number after the decimal, but if we want to go ahead and put it in scientific notation, here's one of those, again, kind of odd cases where I would multiply it by 10 to the 0. 10 to the 0 has a value of 1, so it's still 9.1. It's just shown a little differently. Okay. Part D is 85,000. 85,000. Okay, I got my decimal here. I'm going to count 1, 2, 3, 4 places. So that's going to be 8.5 times 10 to the 4th. All right, and finally, our last one here on example 3 is 0.00074. 0.00074. I want to take that decimal and I want to move it right past the 7. 1, 2, 3, 4 places gets me there. So it's 7.4 times 10 to the negative 4th power. Okay? Everybody cool there? It might be a little different notation for you, but certainly not, you know, rocket science or anything like that. It's just a little different notation maybe than you're familiar with. Right, but we can take any number and put it in this notation. Now sometimes we've got something that's kind of close to the notation, but not exactly. And if you look at example 4 on page 245, that's the case. We have something that's written kind of in scientific notation, if you will, meaning it's got some number times some power of 10, but it's not quite proper because scientific notation, I need to have only one number and then the decimal point. So I need a decimal point after my 3, and I don't have that. I've got the decimal point after that 7. So what you can really just do, and you'll get the hang of it, you won't have to maybe show so many steps, is I'm just going to give myself a little room here and put my 10 to the 5th off to the side here. And I'm just going to convert this as though this were just a regular old 37. Now convert that to scientific notation. So the decimal's here, I got to put it here. So it's going to be 3.7 times 10 to the negative 1 power to accomplish that, right? Excuse me. Times 10 to the positive 1 power. Sorry, I don't want to start this video all over. Bear with me. That's a positive one, right? I wasn't thinking when I said it, but I caught it immediately because if I take 3.7 times 10, I get 37, and that's what I'm trying to recreate. I'm recreating that 37 just differently, okay? All right, but I also had that times 10 to the 5th just tacked off to the side here, so let me write it again. Got 3.7 times 10 to the 1 times 10 to the 5th. Well, I want to consolidate that part, right? The 10 to the 1 and the 10 to the 5th, I want to consolidate. And we all know that when I multiply bases with exponents, I simply add the exponents together, right? So it's going to be 3.7 times 10 to the 6th power. Okay? All right, good deal. Part B. Again, not quite in scientific notation, but it's starting to get that way. We just need to finish it off. So something like this, 0.03 times 10 to the third. Not good. I need to get one number and then a decimal point. So I want my decimal point to be after that 3. So I got to move the decimal 2 places to get there. So I could call that I could go ahead and move it and call that 3 times 10 to the negative 2 power, right? Because now the decimal's here. If I went back 2 places, it would be there. But then I had a 10 to the third out there already. So now I'm going to add these exponents, and I'm going to get 3 times 10 to the 1 power. Okay, is everybody good there? Bear with me as I just look where I am here. That's part B of example 4. 3 times 10 to the 1 power. Okay, I think I'm going to end this video here. Our next video, we actually take 2 scientific numbers and multiply them together or divide them. So we'll get to that shortly.